Have you ever caught a snowflake on your glove and noticed something incredible? Tiny, delicate branches, perfectly balanced, almost like nature designed it with a ruler. But here's the real mystery. No two snowflakes are exactly the same, yet almost all of them share the same six-sided symmetry. So, why does frozen water falling from the sky suddenly start forming tiny geometric masterpieces? The answer begins with something happening at a scale far too small to see. Every snowflake starts as a single speck of dust floating inside a cloud. When the temperature drops below freezing, water vapor in the air begins attaching itself to that particle. But instead of forming a random clump, the water molecules lock together in a very specific way. That's because of the structure of the water molecule itself. Each water molecule contains one oxygen atom bonded to two hydrogen atoms, forming a shape that naturally connects with other molecules at precise angles. When they freeze, they arrange themselves into a hexagonal crystal lattice, a six-sided pattern dictated entirely by chemistry. In other words, the symmetry of a snowflake isn't artistic. It's molecular architecture. But here's where things get even more fascinating. As the crystal falls through the cloud, it grows outward in six directions simultaneously. Each branch experiences nearly the same temperature, humidity, and airflow because they're only micrometers apart. Since all six arms share identical conditions, they grow in almost identical ways. That's why the branches mirror each other. But the moment the snowflake drifts into slightly different air, maybe warmer, maybe drier, the pattern changes. Tiny variations alter how the crystal grows, creating the endless variety of shapes we see. It's like six identical artists painting the same design, while the environment around them slowly changes. This mystery fascinated scientists for centuries. In 1936, a Japanese physicist named Ukichiro Nakaya became obsessed with understanding snowflakes. Working in a cold laboratory in Hokkaido, he spent years trying to grow artificial snow crystals. Finally, he succeeded by carefully controlling temperature and humidity inside a chamber. Nakaya eventually discovered that different conditions produce completely different snowflake shapes: thin plates, long needles, or intricate dendrites. His work revealed something poetic about snowflakes. Each one is essentially a frozen record of the atmosphere it traveled through. But there's one more intriguing idea some scientists have explored. Because snowflakes respond so sensitively to environmental changes, researchers have wondered whether studying their patterns could reveal hidden information about atmospheric conditions, almost like tiny natural data loggers falling from the sky. In a way, every snowflake is a microscopic diary written by the clouds. So the next time snow starts falling and one lands gently on your sleeve, remember this. That fragile little crystal didn't just appear randomly. Its perfect symmetry was shaped by the physics of water molecules, the temperature of the sky, and the invisible journey it took through the clouds. A fleeting piece of geometry, created by nature's smallest building blocks. And here's something to think about. If something as simple as frozen water can produce patterns this complex, what other hidden designs might nature be quietly creating all around us?